So last time what we talked about was the general template of a polynomial function. So f of x is equal to a sub n xn plus a sub n minus 1 xn minus 1 plus a sub n minus 2 xn minus 2 and so forth all the way to a sub 0. And we said that this guy here is the constant. This here is the leading term. The leading term has two things that we need to kind of consider here. We need to consider this portion here, which is the coefficient. It's called the leading coefficient. We also need to consider this power here. Okay, we need to also consider this, and this is called your degree. And the degree is the highest power on a polynomial function. Now, this is important because it tells us a few things about the polynomial function. First of all, we talked about some of this stuff last time, where if the degree is an even number, and this is a polynomial function, then we basically have an even degree polynomial function. If the degree is an odd number, then we have an odd degree polynomial function. Right? So this could tell us a few things about the shape of the graph, right? In the case of an even degree polynomial function, it's going to have similar end behaviors. Okay, so what do I mean by similar end behaviors? Well, either the graph can look like the end behaviors can end up in positive infinity, or the end behaviors can end up in negative infinity. Okay, in terms of coordinates of the Cartesian plane, this would be quadrant 1, this would be quadrant 2, or it could end up in quadrant 3 or quadrant 4. And how we can determine between if the end behaviors will look like this in scenario 1, or if it looks like this in scenario 2, is we'll look at the leading coefficient, right? So if the leading coefficient is positive, then it's going to, the end behaviors will end up in quadrant 1 and 2. And if the leading coefficient is negative, then the end behaviors will end up in quadrant 3 and 4. Okay, so we can look at the sign of the leading coefficient, right? And sub n, a sub n is your leading coefficient. Leading coefficient. If we look at the sign of the leading coefficient, we can actually determine the end behaviors of polynomial function. But in conjunction with that, we need to also look at the degree of the function. Okay. Now we also mentioned that odd degree polynomial functions in case of odd degree polynomial functions, these guys are going to have opposite end behaviors. So what I mean by opposite end behaviors is they will have end behaviors in opposite quadrants. So either it would be in quadrant 2 and quadrant 4. Okay, sorry, that should be a 4. Okay, so either it's in quadrant 2 and quadrant 4, or it can be in quadrant 3 and quadrant 1. Okay, so those are examples of opposite end behaviors. And once again, this is also associated with leading coefficients because there's two options here. How do we know which option fits our graph? Well, in this case, if the leading coefficient is greater than 0, then the graph will look like this. The end behaviors will look like quadrant 3 and quadrant 1, right? You'd have opposing end behaviors because one end goes to negative infinity, the other end goes to positive infinity. And if the leading coefficient is less than 0, which means it's negative, then we would have positive infinity in this quadrant and negative infinity in this quadrant. Okay? So just to summarize, guys, if the degree is a positive number, if the degree is an odd number, Then we have an odd degree polynomial function.